what it behaves like. So the degree is odd, isn't it? And the leading coefficient, these are all ones, right? So if you did 1 times 1 times 1, you just get 1. Now, again, in a 1414 class, it's much harder because we make these numbers something other than 1, which changes this. But here, I'm not going to give you anything more complicated than this. So we know it's going to go down then up, okay? Understand? All right. So we're ready to graph this one. We have to find our x-intercepts and plot some points and bounce and cross, and then we'll be done. So for the x-intercepts, I'm going to set each factor equal to 0. So I set x minus 4 equal to 0, x plus 3 equal to 0, and x minus 8 equal to 0. And I should get 3 solutions: 4, -3, and 8. See, isn't that nice? We didn't have to factor. All right, bounce or cross here? Bounce. Bounce or cross here? Cross. Bounce or cross here? Bounce. I'm looking at 4, 5, and 2. That's what's determining those, right? And I'm ready to draw it. All right, I'm going to plot my x-intercepts. 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. I'm going to draw a dot. At 4, 1, 2, 3, 4, draw a dot. And at -3, 1, 2, 3, -3, I draw a dot. It's going to go down on the left and up on the right. And now connect. So what am I going to do at -3? Cross through, right? So I've got to go and cross through this like that. And then when I get to 4, I've got to bounce. Right? Like that. And then when I get to 8, got to bounce again. That's it. That's the graph of that polynomial function. What do y'all think? Okay. All right, I'm going to give you your homework assignment. I'm going to write it down on the board. So here's what I want you to do. For all of these, the instructions are to sketch. I'd like for you to turn this in next class at the beginning. Let's see here. I want you to be careful on number 4. Specifically, that negative sign. Think about how that would change things. Okay. I'm gonna introduce rational functions. We're not going to get too deep into it, but we're already a little behind, so let me at least introduce those while the sign-in sheet goes around. Let's see, we'll start it back here. Everybody have these? Okay, so these are to be turned in at the beginning of class. Do it on separate paper. Don't do it like in your notes, all right? Yeah, you can take a quick picture if you'd like to do that. All right, we're good? All right, rational functions. I know right now that it doesn't seem like we're doing business anything right now, but that's because we're just trying to get comfortable with functions, and then we go back to business problems. All right, rational functions. A rational function looks like this. You know how I gave you that really ugly definition of a polynomial with those a sub n and all that? Rational functions, here's what they are. You take a polynomial and you divide it by another polynomial. So we just looked at polynomials, didn't we? If you take two polynomial functions and divide them, you now created a rational function. So here's an example. Here's another example. Now I could keep going all day with examples, but let's just understand, is this function, if you look at the numerator, is that a polynomial? Do you see x raised to a power? Do you see more than one term? It's a line, isn't it? Okay, well, I didn't mention this, but all lines are polynomials. Because what was the condition for a polynomial? You just had like x to the n, some number in front, right? Plus another power of x. As long as you have a power of x in there, doesn't matter if it's the first power, second power, third power, fourth power, fifth power, sixth power, they're all polynomials. It's kind of like, here's a way I could explain it. We're all US citizens, right? I think. We're all US citizens. Polynomials are US citizens, right? And then, but these people in this class, most of us are Texans, right? Those are like the lines. So if you're a line, right? If you're a Texan, you're a US citizen. But if you're a US citizen, you're not necessarily a Texan. So there are polynomials that aren't lines, but every line is a polynomial. That makes sense? Quadratics are polynomials. So this is a line over a line. That is a polynomial over a polynomial, and that is a rational function. This is a line over a quadratic. I could do quadratic over a quadratic. I could do a third degree polynomial over an eighth degree polynomial. So you can imagine this opens up a huge can of worms, right? All we want to know here are just two different things about rational functions. The first is if we tried to graph them, where are the x-intercepts? And then are there any other characteristics? You know how the polynomials had those four possibilities, right? Are there any other characteristics of rational functions that we should be interested in? And there are. There's actually two other characteristics. So we have a total of three things we're going to look at. X-intercepts, what we call vertical asymptotes, and horizontal asymptotes. And that's what we're going to have to talk about next class. But I just wanted to at least introduce you to the idea of what they look like in terms of when you write them out as functions. And that's where we'll pick up next class. All right, so make sure you do that homework, turn it in. I'm going to count it as a quiz grade. Y'all have a good day. See you on Thursday. Anybody else need the sign-in sheet? You need to sign in over there? Okay. You finished up? Here you go, guys.